So, good morning, everyone. My name is Aisha Khan. I am from MIT Academy of Engineering, Alindi. So, today in this presentation, I would like to discuss about Verilog. And here I am demonstrating the Verilog codes using 2-bit comparator. So, here we go with the introduction to Verilog. So, Verilog is a hardware description language, that is HDL, used for designing and modeling digital systems, especially at the register transfer level, that is RTL, and gate level. It is widely utilized in the design and verification of digital circuits at various abstraction levels, ranging from algorithmic and architectural levels to gate level implementation. It allows designers to describe the behavior, structure, and layout of digital circuits, such as combinational and sequential circuits. Verilog enables designers to describe the structure and behavior of electronic systems, facilitating the simulation and synthesis of digital designs. Next is key features of Verilog, that are behavioral and structural modeling, concurrency, hierarchical design, test benches, and synthesis. So, behavioral structural modeling is high level algorithm and data flow, that is, how data is processed. So, it describes what the system does like a high level algorithm. Data flow focuses on how data moves between components. Gate level and structural describes circuits in terms of logic gates or predefined modules. Then concurrency, concurrent and sequential statements. So Verilog supports both concurrent and sequential construction. Concurrent statements describe how components operate simultaneously, while sequential statements define behavior based on specific conditions and timing. So Verilog allows creating complex systems using a hierarchy of models, which makes it easier to reuse code and manage complex projects. Basic Verilog syntax. So the first and foremost part of the coding is the syntax or methods, which I'll be doing coding. For very long, what we need to understand that the programming starts with the name of the module and ends with end module. Simple Verilog example for 2-bit adder. So here we'll assign some ports, that is input A, input B, and output is sum. We'll assign sum equals to A plus B and then end module. Here common Verilog constructs are modules, ports, operators, procedural box, and control structures. So the overview of 2-bit comparator. A 2-bit comparator is a digital circuit that compares 2-bit binary numbers typically labeled A and B and produces outputs that indicate the relative magnitudes of these numbers. The comparator outputs show whether A is greater than B, less than B, or equal to B. So comparators are commonly used in digital systems or for decision-making processes, sorting algorithm, and control systems. Here is the diagrammatic representation of a 2-bit comparator. Now designing the 2-bit comparator. Step 1, define the inputs and outputs. So here we define two port inputs A and B, and outputs there is A greater than B, A less than B, and A equal to B. So if A is high and B is low, then it will show A greater than B. And if A is high, B is also high, it will show A equals to B. And if A is low, B is high, then it will show A less than B. Step 2, truth table. To design the logic, we start by creating a truth table for all possible combinations of A and B. So here the truth table represents 4 inputs and 3 outputs as previously discussed. Step 3, derive the Boolean expression. So using the truth table, we can derive the Boolean expression for each output. First, if A1 is high, B1 is low, or A1 and B1 are the same and A0 is high while B0 is low, then it will show A is greater than B. Second, A1 is low and B1 is high, or A1 and B1 are the same but A0 is low and B0 is high, it will show A is less than B. And if A is equal to B when both bits of A and are equal to the corresponding bits of B, then it will show A equal to B. Step 4, Verilog code for 2-bit comparator. So using the Boolean expression, we can write the Verilog code for the 2-bit comparator. So inputs A and B are both 2-bit inputs, and outputs A greater than B, A less than B, and equal to B represents the 3 comparison results. Step 5, test bench for the 2-bit comparator. So here is the code for the test bench for 2-bit comparator. A test bench is useful to verify that the comparator works as expected. So we will discuss both the Verilog and test bench code on the Xilinx software afterwards. Explanation of Verilog code. So here's an explanation of each part of the code and the logic behind it. So module name declares the module giving it the name 2-bit comparator. Then for port input ports, define A and B as 2-bit inputs, and for output define 3 output that represents whether A is greater than B, less than B, or equal to B. So for simulation on the Xilinx software, first we need to run the Verilog code, check the syntax, view RTL simulation, then run test bench, generate waveform, and then verify functionality and implement. So as you can see, I have run the code on the Xilinx software. Successfully checked the syntax and viewed RTL simulation. So in the RTL simulation, as you can see, the output ports given as A equal to B, A greater than B, A less than B. So I'll run the code in the Xilinx software. Then click on the file, then new project, then project name, give your project a name and choose a location. Then project type, select RTL project. And then add sources. So you can add your Verilog source files here or do it later. So I have add VHDL module and name the file, then port name. So I have given 2 input ports A and B and 3 output ports A greater than B, A less than B, and A equal to B. Then next, finish. On the top left corner, there you can see options like synthesis and behavioral model. So as discussed, synthesis is the process of converting a high-level description of a digital circuits into a netlist, which is a low-level representation of the circuit made up of logic gates. So we can run our Verilog code in the synthesis model. So here I have written the Verilog code of the 2-bit comparator and check the syntax. So it is successfully checked. Then I'll check the RTL simulation. So we can view RTL simulation, that is the circuit of our code. So here the output ports and input ports given according to the code. From the top left corner, we will change the synthesis model to behavioral model. So in behavioral model, we can run our test bench. So behavioral model, as discussed, is a high-level description of a digital system that focuses on its functionality rather than its implementation. So for test bench, we will create a new project, and then for sources we will add VHDL test bench instead of VHDL module for test bench. Now in the test bench code, I will write the input ports as high and low. So first both the inputs as low, then A low, B high, then B high, A low, and then at last both the input A and B as high. So after writing the code in the test bench, we can check the syntax again. After successfully checking the syntax, we can see the simulation and the waveform. So here we can see that the waveform is generated. So I have put both the input ports A and B as high, so the output automatically becomes A equal to B. So the waveform is generated accordingly. So in conclusion, the 2-bit comparator Verilog code is a simple yet effective digital design that demonstrates the basics in comparison logic. It uses Boolean expression to compare two bit binary numbers A and B and outputs whether A is greater than, less than, or equal to B. That's all for it. Thank you.